Ladies and gentlemen, welcome to another episode of Science Without Consensus. And boom. I am your host, Diamond, from the Oppenheimer Ranch Project. Joining me is my lovely partner and co-host, Leah Shaper.
Hello.
Welcome to the show. We are going to be talking about October comets. This month is filled with comets, and we're going to attack the latest from Comet 3I Atlas, the third interstellar object that we are able to observe. It is now being observed by satellites near Mars, and we'll go over all of that. We also have two comets that may be visible to the naked eye, Comet Lemon and Comet Swan. We'll talk about their trajectories and their nature, and the fact that all three of these objects we're going to be talking about, 3I Atlas, Comet Lemon, and Comet Swan, are all electric comets. And we'll tell you why.
As if there's any other kind.
Yeah, we'll go over all the details. We'll talk about the old dirty snowball theory, which is currently being spewed by everyone on the internet. And we'll talk about the electric model. So if we have time, we'll get to a discussion on ancient life on Mars. And did they discover evidence of that? And the probability of there being life on Saturn's moon Enceladus, because of some new discoveries, some spectrogram discoveries that show some interesting elements forming that are probably hydrothermal in nature. And we know what happens at hydrothermal vents on Earth. We've got all kind of weird alien life down there.
Mm-hmm.
So I think it would be interesting to get a spacecraft on Enceladus that could bore through the ice and swim around in the ocean.
Yeah, but remember that we have a hard enough time doing that in our own oceans. So,
yeah,
right. This is like still one of the frontiers that needs much more explanation is the deep ocean on Earth.
Yes, indeed. What am I doing? All right. You ready? Do you have any comments before we dive in here?
Mm-mm.
I don't want to do this. Okay. 2 newly discovered comets will be visible in October. It's exciting times, folks. The comets that will be visible are C 2025 R2 Swan. Let's put that baby. And the other one is C 2025 A6 Lemon. They were both discovered in 2025. To see Comet Swan, face west and look up 23 degrees above the horizon in the sky just after sunset. Comet Lemon can only be seen just before sunrise, and that can be seen close to the Big Dipper through much of October. Just look to the eastern sky just before sunrise. Now, according to NASA, here we go. Comets are leftovers from the beginning of our solar system, and they consist mostly of ice coated with dark organic material. This is why they are often referred to as dirty snowballs.
I'd love to know what they think the origin of the organic material that they're claiming is on the surface is. I don't think I've even ever heard that. Have you?
Of what?
This claim of organic matter on comets?
It says most comets originate from the Kuiper Belt or the Oort cloud. These are both fantasy regions beyond Pluto's orbit. When they heat up due to solar radiation, they enter the outgassing phase. This effect causes dust and ice particles to fly into space, creating the dust and ion tails. So some funny stuff coming out there from the mainstream.
Mm-hmm.
And are we looking at a picture? Yeah, this is a terrible shot because we're in front of it.
Yeah. There we go.
Look at that comet. 2 tails. So we've got, the dust tail, they call it, and the ion tail. And it's glowing green. That's pretty interesting. And this is a recent photograph from September 20th. So Comet C 2025 A6 Lemon is just weeks away from a close approach to Earth that could make it visible to the naked eye. So right now you can definitely see it with binoculars or a telescope. And here we have the orbital path of Comet Lemon. It's going to get really close to the sun, and it's already showing signs of electrical outburst.
Mhm.
And so that's
Which will
right here.
probably increase as it gets
So
closer
this
to the
glowing
sun.
coma could increase 10 times as it approaches the sun. It's far away. See where it is?
Yeah.
And so the dark red is the path that's already covered. And so we've got the closest approach to Earth is sometime in late October. There's Earth. So that will be when it curves around here. Oh, my cursor is not on that. Okay.
No.
Let me find it. Right. Yeah. So somewhere around here, it will be closest approach to Earth. And then the closest approach to the sun is, I think, in November. Let me find the exact dates here. Yeah. The closest approach to Earth is October 21st, passing 55 million miles from us. And then closest point to the sun will be on November 8th. So that's where we would be looking for large amounts of activity from this baby. Right near November 8th, like let's say November 1st to November 15th. Because we already know there is an interaction in the field here with the sun that's causing it to glow green and have these tails. Yeah.
By the way, this is really funny. You sent me an article from space.com.
Yeah.
And in that article talking about lemon, they talk about the green coma, it being a result of diatomic carbon. And the words they use are fluorescing in sunlight and its developing tail extending away from the sun. So what I found really funny about that is when you talk about something fluorescing, what you're actually talking about is an electrical phenomenon.
Yeah.
You're talking about the molecules taking on photons from the radiation source and therefore glowing brighter. So it's like there's some acknowledgement of the electrical activity, but yet there's no recognition of the fact that a comet in and of itself is electric. Like that explains every piece of its behavior and appearance. It's really funny.
I agree. All right, let's take a look at Comet Swan. So Swan has already left the building. So let's say we can go back. Oh, no, that's October. Let's go back in time. Around August, Swan was here. This is August 27th, right around my birthday. And now here's September 27th. So sometime like September 15th was the closest approach to the sun. And now it's headed away.
How close is
that's
that?
where it'll be right around Halloween.
Oh, how close is that? Do you know?
To Earth?
Yeah.
Pretty darn close.
That seems like that would be a really good visual for two reasons. One, it's it's not, we're not looking at the sun. The comet is not between the sun and us. And that's a pretty close approach. I don't know how far it is, but.
Let me see if I can find that data. No, I can't find it here. Darn it.
That should be fairly exciting, I'm guessing. Like maybe even bordering on the level of excitement of Halley's Comet in, what was that, 1986?
Look how close that is.
Yeah.
Look at that.
Was Halley's Comet 1980? Was Halley's Comet 1986?
He's getting even closer to it here. October 21st. So that's right around here. But Swan is going to be super close. But you see how the sun is in the way there?
Not really.
Yeah, it'll be much better later in October here. Through the beginning of November.
When we're not looking towards the sun.
All right.
Was Halley's Comet 1986? Do you remember?
We've got this Google.
Yeah, there's that thing, that machine that we can look things up on. Because I was just thinking about how exciting that was when we were kids. You were already a teenager by then. I was like 9. But
1986 March.
It was a big year, 1986. At least in my world, it was. But this seems like Swan should border on that level of excitement, especially with this kind of visual.
And if it does outburst, these comets are almost already visible to the naked eye. So then they will be certainly naked eye comets.
Yeah.
Yep. So let's talk about an interstellar comet that's also electric. Interstellar comet 3I Atlas is now swinging past Mars as a fleet of spacecraft looks on. Let me open this up. So this visual is coming from Tony Phillips. Is that his name? At spaceweather.com.
I can't remember.
Yeah, I forget his name. I think that's his name. Okay. And so here you can see on the chart, what it lists is all the different encounters with the spacecraft that will be able to image 3I Atlas. And so the first one started happening yesterday, and the data is already in, but it hasn't been made public. I imagine it'll be public tonight or tomorrow, hopefully. And that is ESA's Mars Express and ExoMars Trace Gas Orbiter. We're not blocking this. Okay, good.
From just 30 million kilometers.
Yeah, which is pretty far away.
It's funny that they phrase it that way.
These two took pictures of another comet, but it was only 15 million miles away, and they got some pretty good shots. So there's a really good chance that this will work.
Yeah.
If not, right around Halloween on the 30th of October, 3I Atlas makes its closest approach to the sun. And we've got the Parker Solar Probe out there. The 2nd of November, ESA's Jupiter's Icy Moons Explorer, or JUICE, starts observing 3I Atlas near the peak of its activity. Now, Atlas is much further away from the sun than these other comets came. It's between Earth. At its closest approach, it'll be between Earth and Mars's orbit, almost splitting it right in the middle there. So let's go over the history of electric comets. Now, a lot of people, if you just asked them off the street about what to take a guess, they would guess recent, like it's a recent thing, right?
What's a recent thing?
The theory of electric comets.
Oh, I don't think most people would have any idea, honestly, but.
Well, electric universe theory goes back hundreds of years. In fact, around 250 years. Significant scientific hypotheses and theories asserting the electrical nature of comets have been proposed and explored for 250 years. It's crazy. Many natural philosophers, physicists, and astronomers believe that the characteristic physical and light phenomenon of comets were fundamentally electrical. Later, scientists developed more comprehensive ideas based on these early observations. They saw undeniable evidence that comets function as components of an electric solar system, or even more pivotal, an electric universe. Dr. Hannes Tager introduces notable historic figures who invested great resources in this field of research from the late 18th century up to the dominance of the electrical theories at the end of the 19th century. The foundation for new electric view on comets was laid during an epoch when astronomers like Giordano Bruno and Galileo Galilei pioneered a revolutionary new approach to astronomy in general. And this is back in the 1500s. That's insane. So,
I mean, even in light of, let's say, well, for those of you who don't know, there's a very famous book written by Thomas Kuhn, Kuhn, called The Structure of Scientific Revolutions. This is like a foundational book for philosophy of science. And Kuhn is basically the guy that coined the term paradigm shift in the context of science. And his book essentially explains how it takes forever for scientific paradigms to shift and why, all of the reasons why. But even in light of that, the extensive period of time that has gone by with this general failure to recognize electric universe or just even electric comets is kind of astounding. And I think it says something about the I don't know what it is. I don't know what the right term is, but whatever the issue is in astrophysics, astrophysics is seems like such a mess and cosmology, such a mess of theories, like all squished together and people trying to fit square pegs into round holes. I don't know why it's still like that. Why hasn't that whole field just exploded, into so as to make room for a theory that actually makes some cohesive sense, you know? It just seems like an excessively long time for the old paradigm to be still lingering and without recognizing some very obvious phenomena. Let's say just about comets alone.
Yeah,
Like, just forget about all of it, or the rest of the electric universe. Just the comets.
yeah,
Like,
they're
it's so
baffled.
obvious, huh?
They're baffled
Yeah,
each and every
and
time.
yet at the same time, still talking about how comets are fluorescing. Yeah, but it's absurd. Clearly, electricity and magnetism is part of our universe, right? Like, it's not like the current model is that those things are not part of the universe. It's extraordinary, the reluctance to digest any of this.
Right, just the phenomenon of lightning out of thin air.
Right.
And aurora out of thin air.
Right.
They're all electrical discharges. We're aware of it, but we can't extend that off of Earth.
Right.
Absolute insanity. Now, the good news is there's lots of information on electric comets.
Mhm.
This publication comes from a poster presentation at the Institute of Electrical and Electronic Engineers, the IEEE. Now, the IEEE is a scientific group that has accepted plasma universe.
Mhm.
So all of the smartest scientists agree with this.
Mhm.
But yet they still refer to comets as dirty snowballs.
Right.
It's insane.
Well, here's the problem, right? You can be intensely intelligent, but close-minded and unable to shift your perspective, right? So that's part of the problem, is we have plenty of like smart people working in astrophysics and cosmology, but very few people that are able to make a perspective shift or are willing to.
Yeah. For several decades, plasma cosmologists, inspired by the work of Hannes Alfvén, have urged astronomers to consider the role of electrical currents and plasma discharge in large-scale cosmic events. According to these theorists, electricity may be the dominating force in the galaxy and star formation, but only a few have considered the role of electricity might play in spectacular displays of comets. Well, I tell you that all the recent findings in the last several decades support the electric comet model. The popular metaphor for comets as dirty snowballs no longer fits with space-age findings about these bodies. And we keep screaming that, yet we see YouTubers with 1 million followers like Anton Petrov and others spouting the dirty snowball hypothesis. When a theory
Covered in dark organic matter, no less.
Right.
What? Like, where does that come from?
When a theory fails to anticipate discoveries, or the theorists themselves are continually surprised by new findings, it's only reasonable to question the original supposition. We've even landed on comets, and they are rocks.
Mm-hmm.
We've smashed into them, and they are solid. So the dirty snowball model. According to the dirty snowball model, comets are composed of undifferentiated protoplanetary debris. That's dust and ices left over from the formation of the solar system billions of years ago. Radiant heat from the sun sublimates the ices. The vapors expand around the nucleus to form the coma, and it's swept back by the solar wind to form the tail. Over repeated passages around the sun, solar heat vaporizes surface ice and leaves a rind of dust. Where heat penetrates the surface of a blackened, shallow crust, pockets of gas form where the pressure breaks through the surface, energetic jets form, and that is the cryovolcano. So that is the dirty snowball model. What are your thoughts?
Well, you know what my thoughts are. I mean, this is silly. This description sounds completely, it sounds like a fairy tale.
Yeah. So they want like a thin crusted snowball filled with ice.
I get the impression of like a mochi ball.
Yeah.
Except that the outer layer is, instead of being doughy, it's some kind of crust.
Yeah.
Like, if that's the case, then why isn't that crust regularly being blown off? If all of this sublimation of ice is occurring, then how is that rind still in place? Like, that doesn't make
Staying there.
sense.
Yeah. Yeah, it's a stupid theory. I agree. All right, so let's talk about the alternative, the electric comet model. In the electric comet model, comets are debris produced during violent electrical interactions of planets and moons. We've talked about this before. The whole concept of stars and rocky planets as being completely different is probably false.
Mm-hmm.
That like things like our sun and then go out to, let's say, Neptune is like a sun in off mode. Jupiter may be as well. These gas giants are in the in-between. And if we were to go to the center of the gas giant, there would be a solid core that if we removed all the gases and liquids, that solid core, or if we ejected the solid core, it would be a planet like Venus, a rocky planet. And then if a planet hits another planet and breaks up in a billion pieces, you get comets and asteroids. Comets would be electrified pieces that were created during the violent interaction. And asteroids would be non-electrified pieces, just junk.
I wonder, though, if you even need the solid core idea. And the reason I say that is because there seems to be some continuity, let's say, between like an active star and like a dwarf and a gas giant, and then like a solid planet. And the impression I get is like, okay, the star is like, all of the matter is extraordinarily excited, right? It's highly electrified. And then as that star, I'm assuming, ages, becomes less and less active. So it goes from being, highly electrified matter, like plasma is, right? That's essentially what plasma is. It's rarefied gas. Then it becomes gas, and then it becomes like almost like it condenses, right?
Yeah,
because then
that could
because on the
absolutely
opposite
happen. Yeah.
on the opposite end, right? You're sort of having that happening in reverse. Well, not in reverse, but you have something similar happening with the sun, in the sense that a star provides all of the elements of the universe, right? There's again this continuity between something that is almost just sheer energy later becoming solid matter. So I don't know.
Well, the star, you said the star produces all the matter in the solar system. That's it. So a different star is producing different elements in a different solar system.
What do you mean? Are you suggesting that the periodic table is different in another solar system?
Potentially, we haven't ever been there.
Right.
And so we're only detecting the elements we're aware of with our spectrometers because we're aware of those elements. There could be other things we're unaware of that star's producing.
Right. Well,
there's so many different stars. I just found out that the biggest star in the universe, how big do you think it is? How many of our suns would fit inside the biggest sun that we're aware of?
I don't know. I'm going to say something like 100,000.
Yeah, most people guess around there. It's 10 billion.
Holy crap.
10 billion of our sun. Our sun is huge.
Yeah.
But you can fit 10 billion of it into the biggest star
that we know of.
Yeah. That would be bigger than our solar system, that star. That's insane.
I mean, and I think your idea about other solar systems potentially having, producing different elements is also interesting, simply because, we have a hard time rationalizing our own periodic table, right? There's a real rhyme and reason and logic to our periodic table. We have everything organized into columns and rows based on the number of electrons in the outer shell, the number of protons in the nucleus, and there's a real sense in that, because it shows us the relationship between elements and why they're similar in certain respects, why they interact with other elements in the same ways. But we have this problem where it's like the table itself is not shaped correctly, because there's this whole section in the middle that we have to like expand and like somehow fit them all in there, So every time I look at that, I'm like, well, clearly we're missing something about the nature of the universe in this periodic table.
Well, and in recent years, we keep creating heavier and heavier elements artificially. So,
right.
So essentially, you can create an infinite number of elements as long as the technology allows you to create those elements.
Right. And ostensibly, maybe some of those elements in slightly different conditions would actually be able to stick around. Maybe.
Yeah, not here though. So these things they create just are here for an instant.
Well, and you could also make a different argument, like perhaps the elements that we're able to create that only stick around for a millisecond, perhaps they continue to exist like in a parallel universe, or there is a parallel universe where those things can exist simply because the conditions of the physics is different.
Wow, that's sci-fi.
Yeah, it's pretty sci-fi.
All right, back to the electric comet model. So
Yes.
Comets are debris produced during violent electrical interactions of planets and moons. They're similar to asteroids, and their composition varies. They're not all the same,
Yeah.
We know that there are several different types of groups of asteroids, like chondrites and rocky meteorites and iron meteorites. And so these are the same with comets. They're different compositions.
Well, we have this perfect example right now, which is Atlas, right? Which is glowing green because of its chemical composition, which is apparently different than some other comets we've looked at.
Right. And most comets should be homogeneous, meaning their interiors have the same composition as the surface, because they're simply a chunk of a planet that was broken off.
Mm-hmm.
There's no layering. It's just it's a rock.
Mm-hmm.
And it says here, comets are asteroids on eccentric orbits. And I think the orbit has a lot to do with their electrical discharge. As they enter and escape the solar system, they get charged, they get recharged, and they get uncharged.
Yeah.
Comets follow their elongated path within a weak electrical field centered on the sun. This is just what we just said. Mm-hmm. In approaching the sun, a charge imbalance develops between the nucleus and the higher voltage and charge density near the sun. Growing electrical stresses initiate discharges and the formation of a glowing plasma sheath, appearing as a coma and a tail. And we've got a wonderful picture of that.
Mm-hmm.
And our faces are in the way.
Again.
And then Comet Ison looked just like this. Same color, same double tail. And this tail is like hundreds of thousands of miles long.
Yeah.
It's insane.
Yeah.
Yeah, comets are amazing.
Yeah.
The observed jets of comets are not cryovolcanoes. They are electric arc discharges to the nucleus, producing electrical discharge machining, EDM, of the surface. And we've shown you, let's get a barbell comet up here.
Mm-hmm.
The majority of the comets, come on. Barbell. That's not a very good shot. Here we go. Can you see me now? Here you go.
Yeah.
They want you to believe, oh, this is all blurry. I don't want that one.
It's clear on my end.
No, the second one.
Oh.
Which I don't have up here yet. Okay, look at this one.
Yeah.
And this is interesting. And I want to pull this one up because the electrical machine discharging is being photographed here in this picture.
Yep. I
You
can
see
see
it?
it. Yeah. It's faint, but you can see it.
Yeah, there's actually 2 of these cryovolcanoes. No, there's 2 electrical discharge machining zones happening right here. And it's happening in the scour zone, which is why the center of these are barbells.
Right. And yet they want you to believe that these are 2 rocks that somehow magically got like stuck together, and that, you know, despite the incredible improbability of that happening, that apparently happens all the time, because we know of numerous objects that have this barbell shape.
Yeah,
It's absurd.
the majority of them.
Right.
And some of them are being electrically scoured, and we have images of it. That's insane. And no one is talking about this.
Mhm.
Well, the Electric Universe people are.
Right.
Because what we're looking at is direct evidence of how these shapes are formed and why they are so prevalent.
Mhm.
Because these objects are charged just like a planet, right? With a north and a south pole and an
Yeah.
equator.
Right. And
as-
like a planet, they also have an eccentric orbit, right?
Yeah.
Which, you know, the argument here would be that a planet is significantly less charged than a comet, right? Because
Yeah,
otherwise,
because we're moving around a very fixed orbit. The comet
right.
moves through the solar environment in a completely different way. We're not going towards and away from the sun. We stay the same distance. So our charge is pretty stable.
Well, and not entirely the same difference, right? So the charge is going to shift to to a degree, a little for a planet, but like the article says, like the charge potential is going to be changing dramatically for a comet.
Yeah, because they're coming from outside of the solar system directly in towards the sun.
Right.
And then back out again.
Most of our electric interaction or our electrical dynamic is within our own solar system. You know, surely we're affected to some degree by things outside of our solar system, but I'm sure that it pales in comparison. Whereas this comet is being affected by many things outside the solar system.
Yeah. So back to the electric comet, intermittent and wandering arcs erode the surface and burn it black, leaving the distinctive scarring patterns of electric discharges. The jets explode from cometary nuclei at supersonic speeds and retain their coherent structure for hundreds of thousands of miles. The collimation of such jets is well documented, attributed in plasma discharge. So we would be talking about this tail here.
Mm-hmm.
What's even fascinating about the tail, what do you notice in it just looking at it?
It's like it's helical, it's spinning.
Yeah, it's rotating. It's a Birkeland current.
Yes.
It's literally, there's all this direct evidence of scouring, of electrical current, and it's a dirty snowball and a cryovolcano. It's absolute insanity.
Well, the other thing too, go back to the picture of the what is clearly a rock, the barbell. I mean, if this comet were emitting water vapor, you would be able to see that up close. It would be very evident in the photo, but it's not, because it's an electrical phenomena. And when you're not looking at this thing from far back with the contrast of the rest of space around it, like you're inside the coma here in this photograph, basically. You know, so it's like where's the water vapor that's sublimating? Where is it? Like no one asked them this question when they looked at that picture.
So additionally, the tails of electric comets reveal well-defined filaments. And we just showed you a Birkeland current tail there, extending up to tens of millions of miles without dissipating in the vacuum of space. This is a violation of the neutral gas behavior in a vacuum, but is expected of a plasma discharge within an ambient electric field of the sun. So once again, the observations support the electric universe model, that the universe is electric. The closer you get to a star, the more electrical charge you're going to encounter. And comets are like little rocks exposing the electrical nature of our universe.
Yes.
Yeah.
Well, you know what else is funny too? Like this is like it's kind of like looking at lightning, right? Like
Yeah.
it's calling this water vapor is as absurd as claiming that lightning is made of water. You would never see it the way we see it if that were the case. Because like this says, it would dissipate.
Yeah. Where are we at? And so see how the coma is a perfectly spherical in this shot?
Mm-hmm.
I've got so many tabs open.
Yeah.
It's the electric force that holds the spherical cometary coma in place. As the comet races around the sun, the diameter of the visible coma will often reach millions of miles in diameter, and the visible coma is surrounded by an even larger, more improbable spherical envelope of fluorescing hydrogen, which is visible in the ultraviolet.
Yeah.
And so you can kind of see a larger bubble on this, right? You could see a bright blue center and then a fainter, larger bubble.
Kind of. Yeah.
Yeah. But not all comets are the same because, again, they all vary in composition. The rock.
Yeah. 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 Well, that's
So
another funny.
Yeah.
Sorry, go ahead.
They're going to do different stuff.
Yeah.
Yeah.
Well, the other thing that I was finding kind of funny as I was reading some articles, like, you know, they always talk about comets brightening at certain periods and sometimes unexpectedly and whatever. And it's like, what part of sublimating ice would explain sudden brightening of a comet? Like I can understand the coma maybe suddenly appearing larger if the entire coma was a result of sublimating ice, but what would explain it brightening? I mean, I know what their bullshit explanation is. It's this, you know, cryogenic volcanic garbage stuff.
Well,
But
we
like,
read it in the beginning. They say that as it approaches the sun, the core, which is ice, heats up and then builds pressure under that thin rind and then explodes. So if it was an outburst, they would say that a huge amount of pressure built up and then it all was released at once.
well, I understand that, but what I'm saying is that would help explain a larger coma size, but I don't think it would explain it being brighter, because what you have to take into account is fluorescing, which is acknowledged in one of these articles, right? That there's fluorescing happening here, which is why it's green, which is the molecules in the coma are actually taking on photons and getting excited and therefore becoming brighter. Electric phenomena. But
yeah,
that
it's
is never taken into account.
Right. It's a 1,000,000-mile wide fluorescent bulb, so it's electric.
Yes.
Your audio is completely broken up.
Oh no.
Yeah. Yep. All right. What else? The primary distinction between comets and asteroids is that electrical arcing and electrostatic cleaning of the comet nucleus will leave little or no dust or debris on the surface during the active phase. That's a big word, right? Or a mouthful.
What you just read?
If you look at this comet here that's actively discharging,
yeah,
there's no dust on the surface. It's just straight rock.
Mm-hmm.
But on other objects we look at, there are huge fields of debris.
Mm-hmm.
I think that's the one that we slammed a satellite in. That was covered in debris, and that was not discharging. Is some giant object. It wasn't that big actually, but that was two objects that rotate around each other.
Mm-hmm.
Remember that?
Mm-hmm.
Yeah, I forget what those are called.
I don't know. I don't remember
what their names are. All right, so I think we laid out a pretty good case of for electric comets.
Mm-hmm.
And they all have to do with you can't have an electric comet unless you have an electric sun, correct?
I would agree with that.
Yeah. And this goes back into the 1960s. Ralph Jurgens proposed that the sun is a glow discharge, the center of an electric field extending to the heliopause. And some people refer to that glow discharge as a Z-pinch.
Mm-hmm.
The field is the cause of solar wind acceleration, 1970s, Jurgens elaborated the theoretical concept and suggested that a comet's display is provoked by its electrical exchange with the sun. It's a very simple theory.
Mhm.
The comet spends most of its time far from the sun, where the plasma voltage is low. The comet moves slowly, and its charge easily comes into balance with its surroundings. But as the
That's this.
comet falls towards the sun, it begins to move at a furious speed through regions of increasing voltage. And the comet's charge, developed in deep space, responds to the new environment by increasing internal electrical polarization and formed cathode jets and a visible plasma sheath or coma.
This is exactly what we were saying earlier when we were talking about planets versus comets and the electrical charge of each, right? Like the planets are in a balanced it's a balanced setting with its surroundings, with the other
Yeah.
planets and its sun, right? And we're not leaving the solar system, but the comet is different simply because it's encountering environments that are drastically different from each other.
Yeah, I hope that cleared it up for everyone. Do you want to talk about electric comets anymore?
I think we could roll this into some discussion about Mars. You sent me some articles about Mars.
Yeah, let's hit that up. So this is from a rag. The conversation is purely a rag, but that's the best I can do for them. Could life exist on Mars today? Here's what the latest evidence suggests. Recently, NASA revealed exciting details of new findings from Mars. They discovered tiny patterns of unusual minerals in clay-rich rocks on the edge of the Jezero crater, which is, according to them, an ancient lake once fed by Martian river systems and the exploration site of the NASA Perseverance rover. These leopard spot patterns have been hailed as potential signs of past microbial life due to their similarity with traces left behind by microorganisms on Earth. So there is the big announcement that they found life on Mars.
Well, they're claiming they found evidence of past life. And then they say the jury is still out on that.
Right. The problem is that they call electrical discharge features on the surface of Mars ancient river systems.
Right. This is tough, right? Because personally, I think that there's a very good possibility that there was life on Mars at one time. But
Agreed.
we'll get into this, but I mean, there's a sheer lack of curiosity about why Mars no longer has an atmosphere and a magnetic field for science in general. You know, mainstream science seems not really that interested in that question. And I think that's a really important piece of the puzzle. So, you know, we're assuming that Mars experienced a catastrophic electrical discharge situation that would have wiped out all life on the planet, blew away the atmosphere, destroyed its magnetic field, making it impossible for life to exist there. So whatever physical features that might have been on Mars, like lakes or rivers, would probably largely be gone or obfuscated by plasma discharge scarring. You know?
Yeah, there would be no more. The amount of erosion, even though it doesn't have an atmosphere, is epic. There's tornadoes on Mars. They're famous.
Well, because it doesn't have an atmosphere, the level of erosion is going to be insane.
It actually does have a very minor atmosphere and a weak magnetic field still.
Yeah.
There's Mars quakes, there are dust devils. So there's clearly electrical charges sweeping over the surface.
Sure.
But here's the kicker. There's probably 100% probability that under the surface there's life. If you just look at our planet with a good magnetic field, I think it's 99% of all life on Earth is contained under our feet. Mm-hmm. If you take all of the species, 99% are underground. We talked about this in another show.
We did?
Yeah. And so that's got to be the same for other planets. And even though the surface is inhospitable, once you go down in the ground in Mars, there's water and ice, just like on Earth.
And I mean, consider how much life there is in our deep oceans, right? And some of
Yeah.
it being relatively alien to what we usually encounter simply because, you've got like things like bacteria that live on sulfur vents deep in the ocean and therefore largely consume sulfur instead of oxygen, which is, again, going back to the periodic table, makes a lot of sense because sulfur and oxygen are right next to each other in the same column because they have very similar properties in terms of how they interact with other elements.
Yes, agreed. It says here possible locations for Martian microbial life include caves, inside or underneath ice sheets at the poles, or deep underground.
Mhm.
All of these environments have analogs on Earth that host microorganisms. So it is really not a stretch to consider that if life began on Mars, it could still be holding on in these extreme niches.
Mhm.
Yep, I
I
agree.
mean, same way that we have found life on Earth in the seemingly most inhospitable environments, like we were just talking about the deep ocean, even in the Arctic and the Antarctic, right? There's microbial life that, despite what seem like completely hospitable conditions, still persist.
Now,
I
do you
think
think
life
that's
is.
really Mars, or is that just like a fake shot from somewhere in Utah?
How long has rover been up? The Perseverance rover been up there now? It's been a long time, hasn't it? Like
Well,
five
we could
years
just
at
ask
least.
the
We
computer.
could just ask Google.
How long has Perseverance been on Mars? So everybody says 4 years and 228 days.
I was almost right on. I said 5 years.
And usually what happens is dust covers the panel and they lose contact and they break.
But
But I'm like,
you
why
know,
didn't they put a windshield wiper on? Like that was the
well, they
first
must
one
have
they
done
lost.
something like that if it's still working after 5 years.
Oh yeah, they fixed the problem, I think.
Yeah.
But in the ones they lost early, I'm like, you didn't put a windshield wiper on there?
Yeah, it's like that's like basic insurance, right? You spend all of this money and research and development to develop a rover, and then you spend all the money to get it out there, and then it fails because of something stupid like that.
All right, let's talk about this paper that was just published 3 days ago. The detection of organic compounds in freshly ejected ice grains from Enceladus's ocean. Wow. Does that sound good?
Mhm.
I think that this is the breakthrough moment in science happening soon, maybe 15 years from now, where we dive under the ice on Enceladus and it's teeming with life.
Well, don't forget too that there are comets that eject organic compounds as well. We talked about this a while ago. I don't remember which comet it is, but there's one that we detect alcohol from, which suggests fermentation, which is an organic process. Like, I mean, don't forget that like organic compounds by themselves are not direct, they're not evidence. They could suggest life, but they are not life itself, right? They're just organic compounds. But nonetheless, like fermentation, it is a microbial process. It is life, So
Absolutely. Now, the prospect of life other than on Earth in our solar system was revitalized on Wednesday when scientists announced the likelihood has risen that Saturn's sixth largest moon may be habitable after a study found Enceladus is spewing out a wider array of carbon-based substances than previously known. It's really like Enceladus because it has all the conditions that are at the same place at the same time for life to evolve and thrive. It has complex organic molecules and a deep ocean of liquid water. And according to this study, it is thought to have hydrothermal vents, and that would provide a source of energy with the pH, salinity, and temperature of the oceans within the bounds deemed suitable for life. And it wasn't until recently that we found all that bizarre life on deep sea hydrothermal vents here on our own planet.
Mhm.
We were astounded
That was only
that
like
at
10,
such
15 years
depths
ago,
and
I think.
pressures, these entire ecologies could exist
Yeah.
with like nothing to eat. Well, they're eating the whatever's coming out of the vent.
Mhm.
It's absolutely bizarre world. So it's actually like we already have found an alien world on our own planet at
Mhm.
these hydrothermal vents.
Mhm.
Yeah.
Well, I mean, all of this together, I mean, it really suggests that, A, life is pretty tenacious, but also that I'm kind of coming to the conclusion that there isn't such a strong distinction between life and non-life. I mean, we talked on this show a while ago about that the precursors of nucleotides are found on like asteroids and stuff like that, and it's like, when you think about the bacteria that survive in a deep sea environment on hydrothermal vents, because they're eating sulfur. I mean, really, all that's going on is you have a chemical interaction that's going on that allows this organism to continue. There's chemical reactions all the time. Some of them are biochemical, some of them are chemical, but I don't know that distinction is really that. I don't know that it's that distinct anymore.
It's more on a scale.
Yeah. Like it's like almost everything has the potential to become animated in some way. But although, I mean, this is a much bigger philosophical question, which is more about like spiritual energy, right? I mean, there's no doubt in my mind that as human beings, we are souls occupying a body, right? So what is the translation of that for quote unquote lower life forms? And how does that relate to animation exactly? But at the end of the day, all of the chemistry is available in the universe for life to exist, and it seems to be pervasive everywhere, right? We know that from the precursors to the nucleotides that seem to actually be coming from outer space, and that playing into the whole panspermia concept.
Yeah. Yeah. But so we can theorize about panspermia and all the building blocks being bombarded on planets like we did in other shows. But the insane thing, and which is why I think we have to be focusing on Enceladus and getting there. If we find life there, what that means is that there is life everywhere in the universe.
Well, that's kind of what I'm saying.
Conclusively. What?
That's kind of what I'm saying at the end of the day.
It's ubiquitous. It's everywhere. And knowing that, there's infinite solar systems. Can you imagine what is out there?
And why the heck not, right? Because isn't the universe just the infinite expression of God in every possible way imaginable?
It would need all that life to observe itself.
Yes.
Every corner.
Yeah. Yeah.
Absolutely fantastic. Hit the thumbs up. Thank you all for joining us tonight. It's been a great show, exclusively on Rumble, 8 p.m. Mountain Time, Saturday night, and with a replay on our YouTube channel on Wednesday. Bye now.
Bye.